In this lesson, we're going to look at side length properties of regular polygons. And in particular, we're going to focus on the diagonal properties in polygons. The outcomes we're going to cover are: describe and illustrate the diagonal properties of regular polygons, identify and explain an application of the properties of polygons in construction, industrial, commercial, domestic, and artistic contexts, and solve a contextual problem that involves the application of the properties of polygons. So how many diagonals do you see in this triangle? Remember that diagonals connect non-adjacent vertices. In other words, vertices that don't touch one another or aren't right side by side with one another. And in a triangle, all of our vertices are adjacent to one another. They're all side by side. For instance, the top vertex right here is adjacent to this vertex here, and it's also adjacent to this vertex here. And that's all the vertices used up in a triangle. So in any triangle, there are no diagonals. How about in a quadrilateral? Well, I can draw a diagonal connecting one vertex to another non-adjacent, like so. The bottom left vertex and the top right vertex are not side by side, so we can connect them with a diagonal. And I can do the same thing with the top left and the bottom right vertices, which I see here. So in any quadrilateral, this is a rectangle, but this is true for any quadrilateral that you draw, there are two pairs of non-adjacent vertices. So we have two diagonals. All right, next we're going to look at a pentagon. Here we have a regular pentagon. So I'm going to connect as many diagonals as I can find. So I see one here, and I can connect these two non-adjacent vertices. Then I'm going to connect these two non-adjacent vertices, these two, and finally the last pair. So in a pentagon, I saw that I was able to draw 5 different diagonals, and it gives me a star shape in the middle of my pentagon. So there must be some relationship that we can come up with between the number of sides and the number of diagonals. So to do this, to find out how we can generalize this relationship, we're going to look at that pentagon again. And I'm going to label one vertex, vertex A. Now I just want to let you know that you are not expected to know this, but I still think it's nice to see. It's good to show you how to determine how many vertices are in a single polygon. Okay, so how many diagonals can I form from vertex A? Well, in this pentagon, in any pentagon, there are 5 vertices. Vertex A is adjacent to 2 of the 5, so the 2 that vertex A is adjacent to are right here and right here. And vertex A is also one of the 5 vertices in this pentagon. So it is the 3rd vertex. That means it does not form a diagonal with 3 of the vertices, the 2 adjacent to it or itself. But it does form diagonals with the other 2 vertices, which we see here and here. In other words, it forms diagonals with 5 minus 3 of the vertices, which is 2. So for any polygon with n sides, n could be any number, could be 4, 5, 6, 7, 8, 9, 10, whatever number you can think of. A vertex will connect to form a diagonal with n minus 3 other vertices. The reason being, just like in our pentagon here, each vertex is going to be adjacent to 2 other vertices, and it's going to be a 3rd in the polygon. So there's always 3 vertices that any single vertex will not be able to form a diagonal with. So now, whatever size of our polygon is, all n of the vertices, whether n is equal to 5 for a pentagon, or 6 for a hexagon, or 8 for an octagon, or whatever the number is, all n vertices will form n minus 3 diagonals. It'll form diagonals with all but 3 of the other vertices, because it's going to always be adjacent to 2 and be a third itself. So the number of diagonals we see is now n times n minus 3, because all n vertices will make n minus 3 diagonals. There's just one problem with what we have so far, and that is that we've counted each diagonal twice, because each diagonal, like the one from A to this vertex here, each diagonal connects 2 vertices, so we only need one diagonal to connect 2 vertices. So we ended up counting this diagonal twice. When we looked at vertex A, when we looked at this vertex, we counted it, and when we looked at this vertex right here, we also counted this diagonal, which we see here. So that ended up getting counted twice. So we must divide all of our vertices, or all of our number of diagonals, by 2, which brings us to our main formula. The number of diagonals is equal to n times n minus 3 divided by 2, where n is the number of sides in the polygon, or in other words, it's the number of vertices in the pentagon, in the polygon. Now this formula will work for any polygon. What I'm going to show you now, I'm going to put the URL in the chat window for you to use, and I'm going to show you a really nice website that lets you determine the number of vertices, or sorry, the number of diagonals in any polygon of any size. So I'm just waiting for it to load here for me. Here we go. Now, from my recollection, you can access the website yourself, but you can't see what I'm doing in my window. But what is going on in this website is we start with a pentagon, and it tells us there are 5 sides in the pentagon, and there are 5 diagonals, which we also determined when we looked at a pentagon. If you click the More button underneath where it says 5 sides, it'll add an extra side to each pentagon, to each polygon, sorry, and it'll tell us the number of diagonals. So for a 6-sided polygon, or in other words a hexagon, it tells us there are 9 diagonals. In a heptagon, which is a 7-sided figure, it has 14 diagonals. In an octagon, which has 8 sides, it has 20 diagonals. So you can play around with this website yourself and compare the number of sides in a polygon to the number of diagonals it contains. And if you want, you can also test the formula that we've developed and see if the formula actually works. And you'll find that it will work for every single one of the polygons that we do. So to summarize this, again, the number of diagonals in a polygon is given by the following formula. The number of diagonals is equal to n times n minus 3, all divided by 2. And n is the number of sides or vertices.